Okay, so what's the temperature of the surroundings? 60 degrees Fahrenheit. And the initial difference in temperature? Well, 98.6 minus 60, huh? It's going to be 38.6. So it's the difference that's decaying exponentially, right? And 1947 T. So there's our model. That's part A. That's all they wanted in part A. So what's the limit of T as T the limit of the capital T temperature as the lowercase t time goes to infinity? Well, this term is going to go to 0, right? It's approaching 0 asymptotically, so it's going to approach 60 from above, right? Cooling off from 98.6 and approaching 60 asymptotically. All right, so part B. Oh, there is only part B. If the temperature of the body is now 72 degrees, how long ago was the time of death? Okay, so we want to solve this equation in part B. T of T is equal to 70, is that what it said? 70? 72. All right, so that's going to say that 60 plus 38.6 e to the negative 0.1947 t equals 72. All right. Subgoal, isolate the exponential. So start by using the subtraction property of equality. So we get 38.6 times e to the negative 1. That's a lot of times you got to write this number. Equals 12. And then divide both sides by 38.6 to get the exponential all by its lonely self. So that's going to be 120 divided by 386, which we could reduce to lowest terms, always a good idea. That's 60 over 193, so 193 has no factors in common with 60. And so that's in lowest terms. And so you would use a natural logarithm because it's already base e, okay? It's a good reason for using e as the base, because you got a button for that. So it's going to be the log to base e of this ratio. Now I could do this, right? Would this be a good thing to do? First of all, is that true? Yeah, it's true. Log of a quotient is the difference in logs. Would it be a good thing? Well, it's your question. You know, subtraction generally is easier than division, right? So you're doing an easier operation, but now you're doing 2 logs instead of 1. So you have this trade-off, right? So you can do 1 division and 1 log, or you can do no divisions, a subtraction, and 2 logs. Now, if the logs are done by just looking up in a table or something, then that's easier, right, to do the subtraction and the logs, because you just compute the logs by looking them up. But if you're using a calculator, it's probably easier to do this, because it's only 2 operations, right, a quotient and a log. Whereas here we have the difference in 2 logs. So I don't really see that that helps a lot. So I'll use this one, okay? And so what I'm going to do is say t is equal to 0. I'm going to say natural log of 193 divided by 60 over 0.1947. Is that true? Again, I did 2 things at once. Yeah, I took the reciprocal of 60 over 193. Right, and the reciprocal is that thing raised to the -1 power. So you can bring out the -1 and have the reciprocal, and then this negative cancels that negative, and so I've got a positive divided by a positive instead of a negative divided by a negative. And why do I say this is positive? Well, this is negative because it's a log of something less than 1, right? The log of 1 is 0. The log of something between 0 and 1 is negative, right? Log base e. So now I've got a positive divided by, I don't like to accentuate the positive, so yeah, so either way it'll be fine. And what do I get as a number? I don't know. So natural log of the quotient 193 divided by 60, close parentheses, divided by 0.1947. And it's almost exactly 6 hours. Yeah. So this is, you see this in the TV dramas all the time, right? They estimate time of death, and somehow the coroner is able to do that. So this is how they're able to do it, although this 0.1947, I think that's actually a parameter that is much more sensitive to other factors, right? You have to sort of say, if this person were in a bathtub instead of in the open air, that would be quite a bit different, right? That would mean you'd cool off faster, right? Or in a pool, right? That would be a completely different constant then. Or in outer space. Is there murder in outer space? That never happens.
Maybe, you don't know.
Yeah, the space shuttle, you wouldn't know, they cover that up. It'd be scandalous. Okay, so how are we doing? We've got turkey, some boiling water. Why does the boiling water have a calculator next to it and the others don't? Kettle full of water is brought to a boil. In a room with temperature 20 degrees centigrade, after 15 minutes, the temperature of the water is decreased from 100 to 75. Find the temperature after another 10 minutes. So here the unit of time is minutes, not hours or days or years, just minutes. Illustrate by graphing that's why the graphing calculator is there, right? They want you to see that graph and the way it's approaching 20 degrees asymptotic. Okay, now let's take a quick look at